Hey everyone, today we're going to look at the derivative of exponential and logarithmic functions. Now as a reminder, the exponential function with a base of e is e to the y is equal to x. And just a reminder that e represents 2.718, etc., etc. Then the ln of x represents a logarithmic function where the base of that log is e, and therefore the log of e to the x is equal to y. Now, since the ln and e are inverse functions, that means that they would cancel each other out. So if you have e raised to the ln of x, the answer would just be whatever is inside of ln, in this case x. And the ln of e raised to the x would also just equal to x. It would be the exponent since ln and e would cancel. So just to make sure that we understand, here are a few sample problems. If I were looking for e raised to the ln of 2, e and ln would cancel and we're left with 2. If we had ln of e is raised to the exponent of 1, therefore when these cancel, my answer is 1. When we have the ln of e to the 4x, same thing, ln and e cancel, and we're left with 4x. And if you have e raised to the ln of x squared, just like the others, e and ln cancel, and we're left with x squared. So now let's look at how to find the derivative of e. If you have e raised to some function, then the derivative would be the derivative of the exponent multiplied by e raised to that function. So basically, when you're finding the derivative of anything with e, you just copy down the exponential function and multiply it with the derivative of the exponent. So let's try this out. For f of x, we have e raised to the sine of x. If I were to find the derivative, I would find the derivative of the exponent, which is cosine x, and then multiply it to the function e sine x. For b, if I were looking for f prime of x, I'd find the derivative of the exponent, which is 2, and again, just copy down the function. And that's it. Let's look at a couple more. For a, we have f of x is equal to 3e raised to the 2x. So remember that that's just a coefficient, so it's just going to tag along with my derivative. When I find the derivative of the exponent, that is 2, and I have to multiply it with the 3, so 6, and then e to the 2x. For g of x, for b, we notice that we have x squared times e to the 2x. Here, we would have to use the product rule. So here we go. So g prime of x is equal to the derivative of the first term, so 2x, leave e to the 2x alone, plus x squared. And now we find the derivative of e to the 2x. The derivative of the exponent is 2, and then times the function. I can simplify this to be 2x e to the 2x plus 2x squared e to the 2x. This is my derivative. And if you wanted to, you can factor. As you can see, both of these terms have a 2 and an x in common, and they both have e to the 2x. So I can factor out 2x e to the 2x, and I would be left with 1 plus x. For c, we have y is equal to 2x plus 3 times e to the 3x. This is another product. So once again, we have to use the product rule. So y prime would equal to the derivative of the first, which is just 2, then e to the 3x, plus 2x plus 3 times the derivative of the exponent, which is 3, times e to the 3x. We can simplify this a little bit more by distributing everything. So we get 2e to the 3x plus, now here I'm going to actually distribute the 2x with the 3e to the 3x. So that would give me 6x e to the 3x plus 9 e to the 3x because I just distributed the 3. And then I can combine like terms. So my final derivative answer would be y prime is equal to 6x e to the 3x plus 11 e to the 3x. Last one here, we have h of x is equal to the square root of e to the 2x minus 6. I'm going to have to rewrite this with the exponent. So e to the 2x minus 6 raised to the 1/2. Now what we can do here, instead of applying the chain rule, because that would require us to do some more work, I can apply the rule of exponents. And the rule of exponents states that when you have an exponent raised to an exponent, you would multiply. So I'm going to go ahead and distribute the 1/2 to the exponent here. So h of x is equal to e raised to the x minus 3. So my derivative, h prime of x, would equal to the derivative of the exponent, which is just 1, so, and then times itself, so e to the x minus 3. And that would be my derivative. You could have also applied the chain rule, which is totally acceptable, but that's going to be a lot more work. Let's look at a challenge question. Here we have f of x is equal to 5x over 3x squared, and we want to write the equation of the tangent line when x is equal to 1. This particular question is not a calculator question. So if it's not a calculator question, we're going to leave the answer in terms of e, meaning that e would be present in my answer. I won't have like a decimal or anything like that. So first what I need is my point of tangency. So I'm going to look for f of 1, which is going to equal to e to the 5 times 1, so just e to the 5th, over 3 times 1 squared, which is just 3. So this is my point of tangency. Now I'm going to need to find the derivative so I can figure out the slope. Since this is a division problem, that means we're going to have to use the quotient rule. So f prime of x is going to equal to 3x squared times the derivative of the numerator, which is 5e to the 5x, minus e to the 5x times the derivative of the denominator, which is 6x, all over 3x squared squared. I can simplify this just a little bit more. So f prime of x would equal to 15x squared e to the 5x, minus 6x e to the 5x. And everything is over 3x squared squared. You can apply the exponent, you can leave it like this, it's completely up to you. But since I'm just going to plug in a number, I'm not going to bother simplifying anymore. I'm just going to look for that number. So now we're going to do f prime of 1. And that's going to equal to 15 times 1 squared, so 15, times e to the 5 times 1, so e to the 5th, minus 6 times 1, so 6, e to the 5 times 1, so 5, over 3 times 1 squared, which is 3, and then we're going to square that. So 15e to the 5th minus 6e to the 5th is 9e to the 5th over 9, which then our 9's cancel. So we're left with a slope of e to the 5th. So now I'm ready to write the equation of my tangent line. I have my point of tangency, which is the 1 and the e to the 5th over 3. And then I have my slope, which is e to the 5th. So y minus e to the 5th over 3 is equal to e to the 5th times x minus 1. And that would be the equation of my tangent line. Now let's review some properties of logarithms. We're typically just going to work with a lot of ln, and the properties of log do also transfer to ln because ln is log. It's just with the base of e. So these are the various rules that you would need to keep in mind because knowing how to condense and expand logarithms will come in handy when we're finding their derivatives. So for example, the ln of x to the y, this means that we're going to apply the power rule. So that exponent can be moved to the front. And so I can rewrite ln of x to the y as y times ln of x. Now the quotient rule states that if you have ln of x divided by y, we can expand this to represent ln of x minus y, minus the ln of y, excuse me. Then the product rule, the ln of x times y, is equal to the ln of x plus the ln of y. And then we always want to keep in mind that if we ever see the ln of 1, it equals to 0. So let's go ahead and look at how to find derivatives of ln. The derivative of ln is as follows. If you have a function where you get the ln of g to the x, then the derivative would be the derivative of g to the x divided by g of x. So essentially when you find the derivative, the ln basically just disappears. So if I find f prime of x for a, this is my g of x. The derivative of x is 1, and I put it over whatever that is, which is x. So this would be the derivative of the ln of x. For b, we find the derivative inside of ln, so 3x squared plus 2x, the derivative would be 6x plus 2, and we put it over the original function, which is 3x squared plus 2x. For the derivative of the ln of sine x, the derivative of sine is cosine, and we put it over the original function, so sine. And cosine divided by sine is cotangent x. So that's how you find the derivative of ln functions. Now let's look at a couple more examples. For this first one, we have f of x is equal to the ln of cosine x. So the derivative f prime of x would be the derivative of cosine, which is negative sine over cosine x, which sine over cosine is equal to tangent. So my final derivative would be negative tangent x. For b, it's helpful to first rewrite this with the exponent. So f of x is equal to the ln of 2x minus 4 raised to the 1/2. Now when we're finding the derivative of ln, we could certainly apply the chain rule to the 2x minus 4 raised to the 1/2. However, you're going to see that when we're finding derivatives of ln, it is much easier if we can apply any of those expansion rules that we covered and then find the derivative. So this 1/2, I can apply the power rule and move it to the front. So f of x is equal to 1/2 of ln of 2x minus 4. And now it's going to be easier to find the derivative. So f prime of x is equal to the 1/2. Now the 1/2 is just a coefficient, so it's just going to tag along to my derivative. The derivative of 2x minus 4 is 2, and I'm going to put it over 2x minus 4. Now what happens is this 1/2 and this 2 will cancel. So my final derivative is 1 over 2x minus 4. You can certainly factor the 2 out of the denominator if you like, but it's not going to make a difference. For c, we have f of x is equal to the ln of x plus 5 over x minus 1. If we were to find the derivative of just the like what's inside here, like applying the derivative rule right away, we would have to use the quotient rule for the numerator and then put it over x plus 5 over x minus 1, which would give you a complex fraction. So instead, I'm going to use the quotient rule of ln functions, not the quotient rule for derivatives, and expand this function before I find the derivative. So f of x is equal to the ln of x plus 5 minus the ln of x minus 1. This is much easier now to find the derivative because I'm just finding the derivative of each individual ln function. So f prime of x is going to equal to the derivative of x plus 5, which is just 1, over x plus 5 minus the derivative of x minus 1, which is 1 over x minus 1. And see, it's much easier doing this rather than having to apply the quotient rule. Now we can leave your answer like this, or if you'd like, you can write it as one single fraction. It's completely up to you, but this is an acceptable answer. For D, once again, I'm going to apply the power rule of ln and move the 3 and make it into a coefficient. So f of x is equal to 3 times the ln of 6x squared minus 9. So now that 3 just tags along, and when I find the derivative, I have 3 times the derivative of 6x squared, which is 12x, over 6x squared minus 9. Now here, I could actually factor out a 3 from the denominator, so I can cancel it with the 3 that is on the outside. So 3 times 12x over 3 times 2x squared minus 3. These 3's cancel. So my final derivative answer is equal to 12x over 2x squared minus 3. Now we're going to start looking at how to find derivatives using a calculator. So we're going to use the graphing calculator. So I'm just going to pull mine up. Let's just erase everything here. Let's go to my y equals. So for questions that involve more complicated type functions, you'll see that you'll be able to graph the function and then find the derivative just from the calculator. You don't even need to do the actual derivative, like finding what the function is. So let's try this out. So this first function, which is f of x is equal to 3e to the x times sine x, I'm just going to graph that first. So 3, you have e here with the exponent, you have e here that's raised to the first. So I always use the one with the exponent, e to the x times sine of x. Now you always want to make sure when I click on mode that my function is in radians. If it was set to degrees, you would just go down and see it would be highlighted in black. But in calculus, we only use radians. So I'm going to make sure that it's still in radians. Now I'm going to go to my window and I'm going to put the standard viewing window just to see what my graph overall looks like. And now I'm going to go ahead and graph. So we got some wild looking stuff, but it doesn't matter. The calculator is going to find f prime of a. Okay, so we're looking for the derivative when a is equal to 1. So on the calculator, I'll show you now, but we're finding f prime of 1. Where you go, you're going to click on second, and then right here, we're going to the calc menu. And you see that option 6 says dy dx. So I'm going to press the number 6 to select that option. And then what you're going to do is you're going to press the x value that you're looking for the derivative. So I'm looking for f prime of 1, so I'm going to press 1, enter, and then I get my derivative is 11.26, sorry, my calculator disappeared, 2681. Remember that we do not round, we write 4 decimal places and we just truncate, we cut off the number. Now because the derivative is 11.261, this chart here and the last column, we're going to describe what the function is doing, whether it is increasing, decreasing, or it has a horizontal tangent or a vertical tangent. So here, f of x is increasing when x is equal to 1 because f prime of 1 is greater than 0. Let's go ahead to the next function. We have f of x is equal to the ln of cosine x over x squared. So again, I'm going to go to my y equals, and I'm going to put in my function. I'm going to open a parentheses to indicate that we're going to divide ln of cosine x. So ln cosine x, I'm going to close the parentheses for the angle, close the parentheses for the trig function, and close the parentheses for ln, and divide that by x squared. And now we're going to graph. So again, it doesn't matter what I'm looking at right now because again, my calculator is going to do all of my work for me. So I go to second calc, select option 6, and I'm going to put pi over 3. It's important to not estimate pi. We're going to use the actual pi button, which is right here with the exponent button. So I'm going to click second pi divided by 3, enter. And I get that the derivative, so f prime of pi over 3 is equal to negative 0.3722, which you can see here on the calculator there on the bottom. Now, because the derivative is negative, this means that f of x is decreasing when x is equal to pi over 3 because f prime of pi over 3 is less than 0. Let's move on to the next function. We have e tangent of 0.34x. So I'm going to go to my calculator. Again, my y equals menu. I'm going to clear this function out. So I have e raised to the tangent of 0.34x. I'm going to close that parentheses. And now I'm going to graph. Now let's find the derivative. So second calc, selecting option 6, and we're looking for the derivative when x is 0. So I'm going to press 0, enter, and I get 0.3400. So f prime of 0 is equal to 0.3400. Because my derivative is positive, this means that f of x is increasing when x is equal to 0, because f prime of 0 is greater than 0. Now let's try the last one here. We have 5 sine squared of ln of x. Now this is important when you're putting it into the calculator. I have this 5. Now remember, sine squared means that the whole thing is squared. So I'm going to open a parentheses, and I'm going to put that exponent at the very end because the calculator automatically, when you press sine, it's just sine. It's not sine squared. There's no way of really inserting that squared just like that. So we have to do it at the end. So I'm going to put sine and then ln of x. And notice that it opens these parentheses for me automatically. So I got to close for the x. I got to close for ln. And then I have to close for sine. And now I'm going to raise it to the second power. And now we're going to go ahead and graph. And now I'm looking for the derivative when x is equal to 1. So I'm going to my second calc menu, selecting option 6, x is equal to 1, and I get this weird looking number. As you can see, it says dy dx is negative 5e raised to the negative 6. What this means is that this is scientific notation basically, and this is that the decimal point is moved over to the left by 6 units. So if I move it over to the left by 6 units, I have negative 5. I'm going to go 1, 2, 3, 4, 5, 6. So this is 0, 0, 0, 0. And notice that I have these 4 zeros. So it's pretty safe to say, oh, sorry, 5 zeros. It's pretty safe to say that the derivative here is equal to 0. Since we always truncate after 4 decimal points, this just gives me 0. So f prime of 1 is equal to 0. This means that f of x has a horizontal tangent when x is equal to 1 because f prime of 1 is equal to 0. Okay, so now let's start getting ready to tackle some FRQs that involve the calculator. So I put here some things to remember. You can use the calculator to find the derivatives, but you must clearly write out your values and what those values represent. And just like we saw, when trying to find the derivative value, you first have to graph the function, then you're going to use the second calc menu, select dy dx, and you type in the value of x. The derivative, we already know all this stuff, but the derivative does tell us when the function is increasing and decreasing, and depending on whether it's positive or negative. And when we write out if the function is decreasing or increasing, we want to make sure that we include the units that are given, if they are given, okay, because functions are increasing and decreasing at a particular rate. So I put an example here. If we get that the derivative is equal to 3, and we are given that our units are meters and seconds, that means that the function is increasing at a rate of 3 meters per second. So just as a reminder, that slope is a rate. So you must always include the unit of measurement over the unit of time. And what the derivative tells us is the rate at which the function is changing. Okay, so those are some important things to remember when we're answering a calculator FRQ. Now let's go ahead and look at a couple of FRQs. For this one, we have the number of people entering a concert can be modeled by the function f of t is equal to 560e raised to the sine t, where t represents the number of hours after the gates are open. So find the values of f of 1/2 and f prime of 1/2. And using correct units, explain what each value represents in the context of the problem. So just as a reminder, right, t represents the number of hours. So if we're plugging in t is equal to 1/2, that means that we're finding out for f of 1/2 how many people have entered the concert, because the number of people entering the concert is f of t, after 30 minutes. For f prime, we're looking at the rate of change. So how many people, or rather the rate at which people are entering the concert after 30 minutes. So let's try this out. Remember, the calculator is going to do this for us since this is a calculator question. So first I'm going to find f of 1/2. So I'm going to go to my calculator here. I'm going to go to my y equals menu, clear out this function, and I'm going to graph that function 560e raised to the sine t. Remember that this calculator, you just can't really change the variable. We're always just going to use x. And now we're going to graph. It's still working. Okay, now notice when I graph, I see nothing. And this is because we probably have a much larger viewing window. Now, I don't necessarily know what this viewing window is, and that's okay. What I'm going to do is I'm going to go to zoom, and I'm going to go to zoom fit. So you can just scroll up or down until you find zoom fit, press enter. And what it's going to do is it's going to find the most relevant parts of our graph, which is this. And now I'm going to go to second calc. I'm going to put value, and I'm going to put 1/2. So I can get my f of 1/2, which we get here is 904.4819. So I'm going to write that out, 904.4819. Now what does this mean? This means that after 30 minutes, because t is 1/2, 904 people. Notice that I'm not using the decimal because this represents people. So since it's 904.4, I'm not going to round. I'm just going to use, it's a total of 904 people have entered the concert. Now I'm going to find f prime of 1/2. And again, this is just the calculator. It does it for us. So I'm going to come here. I'm going to go to second calc. And now I'm going to click on dy dx. and I'm going to put 1/2. And I get 793.7573. So f prime of 1/2 is 793.7573. Now this means that after 30 minutes, remember this is a derivative, the rate at which people are entering the concert is increasing because the derivative is positive at a rate, and now we describe the rate of 793 people per hour, since those are my units. Remember that f of t represents people and t represents hours, so we would say people per hour, just like slope. For the next part, we have if 50 VIP concert goers were allowed into the venue before opening time, how many people were at the concert 2 hours after the gates were opened? Is the number of people increasing or decreasing at this time? And justify your answers. So, if I want to figure out how many people are in the concert after 2 hours, we're looking for an amount. We're not looking for a rate. So this means that I am trying to find f of 2. And that's going to tell me how many people have entered the concert after 2 hours. But we have 50 VIP concert goers that were already in the venue at that time. So I would have to add 50. So I'm going to look for f of 2 from my calculator. It is the same exact function. So again, second calc, I'm going to select value because that's for f of 2. I'm going to press x is equal to 2, and I get 1,390 for f of 2. That's how many people, plus 50, which is going to equal to 1,440. So 1,440 people are at the concert 2 hours after the gates are open. Now I'm going to figure out, is the number of people entering increasing or decreasing? This means that I am trying to find f prime of 2. So I'm going to go back to my calculator, second calc, dy dx, 2, enter, and I get negative 578.5451. So negative 578.5451. Now what this means, we're just going to answer the question, the number of people entering the concert after 2 hours is decreasing because f prime of 2 is less than 0. Let's look at another FRQ. After being poured into a cup, coffee cools so that its temperature, T of t, represented by the function T of t is equal to 70 plus 110 e raised to the negative t over 2, where t is measured in minutes and T of t is measured in degrees Fahrenheit. So this is nice because your units are outlined here for you. T is minutes and T of t is degrees Fahrenheit. What is the temperature of the coffee 5 minutes after it has been poured into the cup? Notice that we're looking for temperature, not the rate of the coffee, like temperature decreasing or increasing or anything like that. We're looking here for the rate, the actual temperature. So what I'm looking for here is T of 5. since t, or little t, right, is in minutes, and this is 5 minutes. So now what I'm going to do is I'm going to go to my calculator. I'm going to go to my y equals, and I am going to graph this function. So 70 plus 110 e raised to the negative, I'm going to open parentheses, well, no, not really, I don't need to, x divided by 2, and enter. And now I'm going to go ahead and graph. Now it's probably going to use the same window that I had before. So what I'm going to do here is I'm going to go to my window, my zoom, and I'm going to go to zoom fit. And here I get a better view of my graph. So now I'm just looking for the function value. So I'm going to go to second calc, click on 1, and press 5. And I get 79.0293. Remember, 4 decimal points, and we have to put the units. And this is degrees Fahrenheit. And that's it. We don't have to explain anything here because it doesn't say so. For part B, however, it does say, is the temperature decreasing faster 1 minute after it is poured or 3 minutes after it is poured? So we already know that these derivatives should be negative, but we want to see how negative. Is it more negative at 1 minute or is it more negative at 3 minutes? And this will tell me whether it's decreasing faster at 1 or 3 minutes. So I'm going to find first t prime of 1. And then I'm going to find t prime of 3. And I'm going to compare those values. So I'm going to get my calculator here. I'm going to go to second calc. I'm going to click on my derivative option. 1, enter. And I get negative 33.35919. So I'm going to write that out just so that I don't forget. So negative 33.35919. I put a little extra decimal point, no big deal. Now we're going to go ahead and do the same thing, but for 3. So I'm going to go back to my menu, I'm going to click on derivative, enter 3, and I get negative 12.27216. So now I'm just going to write that down. So that means that t prime of 3 is equal to negative 12.2721. Is that right? Let me go back. Yes. Now what does this mean? This means that after 1 minute, the cup of coffee is cooling down, or the temperature is decreasing faster at 1 minute rather than 3 minutes. And I'll explain the reasoning now why. So the temperature, you basically can just restate the question so that way you're using the proper wording. The temperature is decreasing faster after 1 minute that the coffee is poured because t prime of 1 is more negative than t prime of 3. You could also write, in addition, that the absolute value of t prime of 1 is greater than the absolute value of t prime of 3. And this just means that this value is greater than this value when you take away the negatives. So meaning that it's greater than the t prime of 3. And that's derivatives of exponential and log functions, as well as how to use the calculator for FRQs.